Huh. Good evening, ladies and gentlemen. This is David de los Reyes. My lesson for tonight is lesson number 10 on integral calculus. Okay, let's proceed. The topic for tonight is integration of trigonometric functions. Integration of trigonometric functions. Trigonometric. It involves angles. We are now through with the integration of exponential functions, logarithmic functions, the sum and difference of terms. So let's now proceed with the next topic. It's a gradual sequence. And the topic for tonight is integration of trigonometric functions. Okay, I will try to bring out the 6 integration formulas for trigonometric functions, trigonometric. If under differential, we got 6 equations for differentiating different functions. Under integral, it's the same. There are still 6 formulas. Okay, I will give you the formulas, then I will give you the derivation later on. Okay, number 1. The integral of sine of b dv equal to cosine of b plus c. That's formula number 1. If you are integrating a sine function, the integral of that will be the cosine of that function plus c. I will bring out the derivation later on. The integral of cosine of b dv equal to sine of b plus c. The integral of any cosine function will be equal to the sine of the given function plus c. Okay. Number 3. The integral secant square of b dv, and this is equal to tangent of b plus c. The integral of any secant square function, okay, times its differential, the proper integral will be the tangent of the given function plus c. That's number 3. Number 4. The integral of cosecant square of b dv, this is equal to negative cotangent of b plus c. Cosecant square, it should be the cotangent of that function, but it should be preceded by negative sign. This is plus c. Number 5. The integral of secant of b, tangent of b dv, the proper integral will be the secant of b plus c. Secant tangent, the integral is secant, this is plus c. Number 6. The integral of cosecant of b, cotangent of b dv, the integral of that should be cosecant of b, but it should be preceded by negative sign. This is plus c. So actually, there are 6 additional formulas to be studied under integral calculus. So you must have to memorize these 6 formulas by heart. Number 1, number 2, number 3, number 4, number 5, number 6. Okay? Okay, I check my camera. We will bring out the derivation. We will bring out formula number 1. Derivations. For number 1, we will let y equal to cosine of b. That's our representation. Take the differential of both sides. the differential of y equal to the differential of the right hand side. The differential of y is dy, and the differential of cosine, we are familiar with differentiation. The differential of derivative of sine is plus cosine. Cosine, it is minus sine, okay? The derivative of a cosine is minus sine. So this is minus sine of b dv. The derivative of a cosine under differential calculus is the sine value, but it should be preceded by negative sign, okay? Just recall your differential calculus. Take the integral of both sides. The integral of dy equal to the integral of sine of b dv. Rearranging, we put this one on the left, we put this one on the right. There's a negative sign inside, we bring it out. So this is open quantity, close quantity, negative 1. The integral of sine of b dv, the right hand side, we put it on the left, equal to the integral of dy. Okay? Then try to multiply all the terms by negative 1. Right? Meaning, left and right multiplied by negative 1. Negative 1, okay? The right hand side will now be plus. Okay? Negative 1 times this is plus. This is actually plus 1 over here. Plus 1 times minus 1, this will now be equal to the negative integral of dy. The integral of the differential of y is just y. When the integral sign goes near the differential sign, they will cancel each other. So the right hand side will just be simply y. But this is supposed to be preceded by negative sign. This is negative y plus c. But what is y? Y is cosine of b. So formula number 1, the integral of sine of b dv equal to negative cosine of b plus c. Is it correct? Yeah, it's correct. That's it. Okay, let's proceed with number 2. For number 2, we will let y equal to sine of b. Okay? Take the differential of both sides. The differential of y equal to the differential of sine of b. The differential of y is dy. The differential of sine of b is cosine of b dv. Okay? Okay? Then take the integral of both sides. The integral of dy equal to the integral of cosine of b dv. Right? We put this on the left, we put this on the right. The integral of cosine of b dv equal to the integral of dy. The integral of the differential of y is just y. Okay? Plus c. But what is y? Y is sine of b. Therefore, the integral of cosine of b dv equal to sine of b plus c. That's formula number 2. Okay? Number 3. We let y equal to tangent of b. Take the differential of both sides. The differential of y equal to the differential of the right hand side. The differential of y is dy. The differential of tangent, or the derivative or the differential of tangent is secant square, okay? So it should be secant square of b dv. Then take the integral of both sides. Then we rearrange, we put this on the left, we put this on the right. Therefore, the integral of secant square of b dv equal to the integral of dy. Then this will cancel out. The integral of dy is just y. This is plus c. But what is y? Y is tangent of b. So in general now, if we are integrating secant square of b db, the proper integral will be tangent of b plus c. Simple, right? That's formula number 3. The integral of any secant square function db is equal to the tangent of the angle plus c. It is this. Number 4. It's easy, right? We let y equal to cotangent of b. Take the differential of both sides. The differential of y equal to the differential of the right hand side. The differential of y is dy. The differential or derivative of cotangent is its cosecant square preceded by negative sign. Recall your differential calculus, okay? dy is equal to negative cosecant square of b db. Then take the integral of both sides. Take the integral. Okay? We put this on the left, we put this on the right. Open quantity, negative 1, close quantity, the integral of cosecant square of b db. Because there was a negative side, we bring it out. Equal to the integral of dy. Then we multiply all terms by negative 1. Negative 1. Negative, negative, the right left hand side now will be plus. Negative 1 times the integral of dy is negative, open quantity, negative 1, close quantity, the integral of dy. This will cancel out. Negative 1 times y is minus y plus c. But what is y? Y is cotangent of b. Okay? So the integral as a final formula of cosecant square of b db equal to the cotangent of b preceded by negative sign plus c. That is actually formula number 4. It is this. Cosecant square of b db, the integral is negative cotangent of b plus c. It is this. So actually, the foundation of integration is differentiation. We are deriving the formula by using our knowledge of differentiation. Number 5. For number 5, we let y equal to secant of b. Take the differential of both sides. The differential of y equal to the differential of secant of b. Differential of y is equal to the derivative or differential of secant is secant tangent. Secant of b, tangent of b, db. Secant, then tangent. Then take the differential of both sides. We put this on the left, we put this on the right. So the integral of secant of b, tangent of b db, equal to the integral of dy. The integral of dy is just simply y. Right? But what is y? It is secant of b. So in general now, the integral of secant of b, tangent of b db, equal to secant of b plus c. That's formula number 5. Not so complicated equations, right? Number 6. For number 6, we will let y equal to cosecant of b. Take the differential of both sides. The differential of y equal to the differential of the right hand side. The differential of y is dy. The differential of derivative of cosecant. Cosecant is a negative cosecant cotangent. So this should be negative cosecant of b, cotangent of b db. Okay? We are recalling our differentiation formulas. Then try to take the integral of both sides. Okay? There's a negative sign over here. We put it on the left. So I place a negative 1 outside. The integral of cosecant, cotangent of b db equal to the integral of dy. Right? Then multiply both sides by negative 1. Negative 1, negative 1. The left hand side now will be plus. The right hand side will be the integral of dy times negative 1. It should be negative the integral of dy, or just simply negative y. Negative y plus c. It's not a magic. We bring the negative sign on the right by multiplying all the terms by negative 1, right? But what is y? Y is cosecant of b. So in general now, the integral of cosecant of b cotangent of b db equal to cosecant of b plus c. Negative cosecant of b plus c. That's actually formula number 6. Okay. Any problem with it? There's no problem. So the next time around, I will give you example problems involving these 6 integration formulas for trigonometric function. The integral of sine is cosine, the integral of cosine is sine, secant square is tangent, cosecant square is negative cotangent, secant tangent is secant, and cosecant cotangent is negative cosecant. Actually, this is the complete derivation by using our knowledge of differential calculus. It's an easy thing in integral calculus if you are familiar with your differentiation plus your algebraic manipulation. I think that's just more than good enough for tonight. If you like it, please click like. If you want to share it, please click share. And if you want to subscribe to my channel, please click subscribe. For those who are taking up integral calculus for the first time, this is a good discussion on your part. It's a gradual thing from start to finish. You will learn integral calculus the gradual way, concise explanation, not too long, very brief but straightforward, understandable. Thank you.